Hello everybody, this is Lukasz Fikus, broadcasting straight from Tampa, FLA. We were planning to make a 3-episode series about the DAC, and it turns out that 3 is not enough. So to talk about this amazing product, our pride and joy, our flagship, we went for the 4th, 5th, and now it's a 7th chapter, and there will be one more, number 8, and that will wrap up the brief history of the Horizon DAC. Episode number 7, we want to discuss a little bit the internal circuitry, and I wish we could have a small camera and all the lights and all the editing tools, but it's just a teaser. We will show the internals of the DAC when we broadcast from the factory, but here we can only talk about it, so I will try to use your imagination and use my limited vocabulary to explain what is inside, like why exactly this beast is 112 pounds before packing. It's very heavy, and we did not put stones or any lead inside. It's all, every gram has a justification, and we made it as light as possible. So we extruded, by using the CNC machines and tools, we extruded every piece of aluminum we could extrude to make it hollow, but it's still completely solid, like a rock chassis. The chassis must be strong to hold all the internals in transportation, in intercontinental flight, so nothing can be detached or broken or bent. It's also very elegantly made piece that is your pride and joy when you own it, when you put it on your rack. You feel that it's very solidly made and that it deserves the flagship status. But what's inside in terms of electronics? Let's start from power supply. We don't use any impulse power supply. It's an easy shortcut. It's a simple way to achieve your desired voltage and current. It's probably much cheaper than anything else, the impulse kind of switch mode power supplies. We decided to not use them for various reasons, sound quality being main reason, and then reliability, longevity, etc., etc. So everything we use in this DAC is traditional linear power supply, meaning that we need transformer, and we need a bridge, and we need a capacitor filtering network. The transformers, to avoid humming, avoid any kind of overload, avoid any kind of stress or distortion of the sine wave produced, the transformers are oversized. So we have 3 power transformers inside. Each of them is roughly around 100 watts. So we have 300 watts of potentially available power, even though we only use 65 watts at the end of the day. So there is some headroom and protection from going into the dangerous humming zone, because the transformer, when it's loaded correctly, is silent. When it's the load increases versus its core cross section, because the power of transformer is mainly decided by the cross section of iron. So as the load increases, it starts humming slightly, and then it starts buzzing, and then it starts overheating, and then it goes into the meltdown. So we wanted to stay as far away from the meltdown zone, you guessed right, as far as possible. So three transformers, 100 watts each. One transformer is dedicated only to the digital section. One transformer is dedicated to the tube section in all the low voltage needs, like heaters, like biasing and the filament of the rectifier. Then high voltage, which is the most important in tube design. The high voltage that goes on anodes of all these tubes is made by the specialized EI transformer, so it's a traditional cubical shaped transformer, and it's supplying the 8 anodes of these tubes. 3 transformers means 3 times the 100 watt core, and then the copper. We have primary windings, we have screen windings, we have also secondary windings, those that provide precisely correct voltage to the various elements of the circuit. We have 17 power supplies in total, so there is 17 separate windings to avoid crosstalk, avoid sharing the load, avoiding overload, and generally this results in a beautiful sound, very clean and very transparent. 17 secondaries, this is something unheard of. Our best DACs from 7 or 8 years ago only had 4. So this is a big progress. It's an expensive progress. That's why this is a flagship. We can't cut any corners. So just to give you an example, just the USB module has 2 separate transformer windings to allow galvanic isolation between the grounds and between the signals, so that when we plug the computer environment and the USB cable is galvanically, means totally isolated from the DAC. So there is no ground loop, no noise coming from the computer, neither or on the 5-volt line, which we don't use, it's cut off, and nor on the ground line, which is connected but opto-isolated. And this is only possible if you have dedicated transformer with 2 windings. Digital section is super complicated. It's about 3 times the part count of the previous Pacific DAC, and by part count I mean complexity and sophistication of the digital, as we call it, engine, digital section. The digital section has 2 major areas of concern, 3 major areas of concern. One of them is receiving all the digital signals that we discussed in episode 7, so all the data formats and all the data inputs, all the data cables and all the plugs that are commonly used. They go through various stages of input receiving, and then managing this file, and then converting them to I2S, and then feeding them to the DAC section. Each of these tasks and each of these chips, and then there is also a microprocessor that runs the shows, so decides about all functionality, and opto-isolators again, and very high-speed data couplers. All that is separately fed from separate power supplies. There's 12 of them in the digital section, so makes it as clean as possible, and no 2 processes in the whole product share the same winding of the transformer, and hence the power supply. Of course, all the diodes are Schottky bridges, which are the cleanest, the most elegant diodes that one can use. And then there is the whole area is one giant PCB on the top, which is the analog section holding the tubes. Again, every function is separately fed from separate power supply. Every tube has a heater from separate winding and separate power supply. And there are also relays, muting circuits, and all the functionality for data for power slowdown as the on a switch on cycle, the voltage is rising slowly, the heaters are rising slowly. All this is managed by the microprocessor or by specialized circuits. So all in all, there is no complexity that we could possibly add to make it better. You could have another idea or another design, but in this design we use the maximum possible complexity of power supply in order to make everything simple, clean, and trouble-free. So, for example, any possible failure can only affect one line, and then it's very easy to replace or change or fix because we know what failed. So the resulting design is very quiet. No stethoscope, for like a doctor's stethoscope, can detect any vibration or hum coming from the DAC. It is silent as a stone. Whether it's used in a 230 volt environment or 115 volt environment or 240 volt environment. So it will not vibrate, it will not hum, it will not affect the microphonics of the tubes. It will never be overheated or overstressed. The power supply should give practically infinite longevity. All the transformers are first impregnated when they are after winding, and then they are put in vacuum chambers with special resin compound, and the resin penetrates the windings and also solidifies it as a stone, and then they are placed in a big iron cups that shield them from magnetic fields, and they are potted again and filled with epoxy resin. So the whole assembly is a 3-level impregnation and potting encapsulation, which is the maximum known in audio design kingdom. So we think that we've addressed the power supply in a most high-end mode that you can possibly think of, and hence the product is our pride and joy, and it should last the lifetime as your flagship component and the center of your entertainment system. Thank you for watching, and I encourage you to see number 8, which we will deal with the rear panel and all the incoming plugs, cables and signals. Thank you.